Hi everyone! We are Team rizzcue from Raffles Girls' School participating in 2024 RoboCup. I'm Chloe Chong, the team leader / software head. My experience in robotics is 3 years and I've participated in RoboCup 2023.
I'm 𝙍𝙤𝙗𝙤𝙦 and I'm the software lead, and my experience is I've been in robotics since P3 and have participated in RoboCup 2023.
Hi everyone, I'm Estelle Chua. I'm the hardware lead. My experience in robotics is 3 years and I've participated in RoboCup 2023.
Hi everyone, I'm Etinia Hong, the hardware lead, and I've been in robotics for 1.5 years and participated in WRO 2023.
For our executive summary of the challenge, the task is through following a black line on the floor which forms a path which the robot is required to navigate through. The robot may face speed bumps or obstacles such as bricks, blocks, weights, and large heavy items. There are intersections which could be placed anywhere on the map except the evacuation zone. The robot has to turn on command in the right direction upon sensing a green square. There will be ramps which the robot would need to climb up and down from different levels. In the evacuation zone, the robot has to rescue victims which are represented by balls to be deposited in the evacuation points in the corners of the area, and the robot will detect and sort the different colored balls into the respective zones.
Our robot's design contains mainly an EV3 brain, 2 large motors, 1 medium motor, 1 ultrasonic sensor, 2 color sensors, and 1 touch sensor. The 2 color sensors attached in front of the robot facing the mat serve the primary and most important purpose of following the line and detection of the green squares in order to carry out respective functions by differentiating the scaled value of RGB. This helps to ensure that the bot is able to navigate through the map via line tracking. The rubber grooves are attached to the tracks to increase the friction between the tracks and the ground in order to increase the grip and prevent the robot from slipping or toppling. The large motors are connected to EV3 tracks, which were chosen over wheels to overcome the ramps. The tracks have a larger surface area in contact with the floor. This not only increases the friction between the tracks and the ramp, but also helps increase the weight distribution of the robot, hence preventing it from toppling over as it climbs the ramp or runs down the ramp. The touch sensor is used to detect the obstacles on the line track path, and upon detection, the ultrasonic sensor will constantly track and maintain a fixed distance from it such that the robot will maneuver in a semicircle around it before going back on track.
Software design and rationale. We have adapted a method where after calibration from the color sensors, we will input a range of values into a variable, and if the color detected by the color sensors falls into a particular range of values, the robot will perform a sequence of actions. Touch sensor. Upon being touched, it will trigger a series of code. The robot will then move around the obstacle and sense for a black line before returning on track. Line tracking. For the segment of line tracking, by constantly keeping a lookout for the color white in the color sensors and afterwards correcting itself to continue onto the right path for line following. The code was named proportional control, where the scale values of these RGB colors for both sensors were compared to obtain the error before multiplying the error by kp. Green squares. It is a similar concept for green squares, where when a change in RGB is detected and the value suits the range of values for green, the robot will then turn in either left or right green or a 180 degrees turn.
For our strategies and innovative solutions, to tackle the issue of a false positive where the robot detects a green square behind the black line and where it is not supposed to turn, we have implemented a strategy. Whenever the color sensor detects double black, it will retreat to detect a green square. If no green squares are detected, it will proceed to move forward. However, if there are green squares, the robot will turn in corresponding direction. Similarly, upon detecting a green square, the robot will first move back to check for a black line. If present, the robot will continue moving forward. Otherwise, the robot will then proceed to continue turning in its corresponding direction.
AI tools used. The only tools we used was the EV3 official website to search for basic commands for the different EV3 compartments to search for simple programs whenever we face a hurdle. Knowledge sharing. Resilience and determination is important, as you might get stuck at a problem or error for some time without a clear solution to the issue. But being resilient and still working through it, despite the obstacles, is important. Thank you!